Remember what ANOVA is. You're looking at more than two groups, 3 groups or more, and your data is at least metric. So to do the analysis of variance, we got to go and compare means. We got to go to ANOVA here, one-way ANOVA. Click on this. Now I've already set this up for the previous class. So we have these as our 4 dependent variables. Hair is our independent variable. You don't have to tell it what the categories are. It seems to be okay with this. But you also have to go in here into post hoc, and you have to make sure the Chaffee area is checked. And you got to change this. It's going to be 0.05 when you get in here. You have to change this to a 0.10. All this is given to you in the procedure. And I think there's something else you're supposed to do. There's an options button. You have to go into the options, and you have to make sure that you check this homogeneity of variance test. And then hit continue. And then you hit OK. We're going to get 4 ANOVAs here. Okay, first thing you check on the ANOVAs is whether you have a valid ANOVA or not. It's not valid unless all of your variances are considered equal. This is testing for my 3 hair color groups, whether the variances are equal for each of these 3 dBs. So 0.156, what does that mean? We're accepting that the variances are equal, because this is bigger than 0.10. Remember, always compare this to 0.10. If it's less than 0.10, reject. Bigger than 0.10, accept. So the variances are equal for this one. So that's good. That means we have a valid test. For the second one, they're not equal. Variances are not equal. So I don't have a valid midterm 5 result. What can I do if I want to analyze midterm 5 versus the hair color? I have an option that I can do. What is it? I can run the Kruskal-Wallis test. I can run the Kruskal-Wallis test. Okay, worth. Do I have a valid test or not?
No.
I do. It's bigger than 0.10. It's a valid test. The variances are equal. That's valid. For this one here down below, it's not valid. Below 0.10. So I can run a Kruskal-Wallis test on Dulles excited. That will be valid. So the only 2 I have that are valid are number of days to respond and worth. So let's go ahead and look at those. Number of days to respond, my p-value is this, 0.939, which tells me the means are what, equal or not equal?
Equal.
They're equal. I'm accepting that the means are equal. Accepting that the means are equal. Now if I go down to worth, what do? I accept that the means are equal or not?
Yes.
Same thing. It's greater than 0.10, I accept that they're equal. I don't look at the midterm, I don't look at this because they're invalid tests. Now if I go below here and look at the subset stuff, the Chaffee test, how many subsets am I going to get for number of days to respond and worth, since the means are equal? So I just want to know how many subsets am I going to get. Remember, the subsets tell you the cases where the means are different. They're saying the means are all equal, so how many subsets are going to get? Just 1, and 1 down here. So if you look down here for this, you'll see speed of response, they're all in 1 subset. The means are all equal. And if you look down for worth, all the means are equal. They're all in the same subset. If the means were different, you would see different subsets coming out here. If all 3 were different, you get 3 subsets. If only 2 of them were different, you get 2 subsets. Questions? Okay, so between now and we meet you on Tuesday, you've got your data collected. Enter your data into your data file, create your data file, and you can start doing some analysis. You'll have a much better idea of what kind of analysis to do after